Welcome everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those still in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first we'll go through some reminders. Please feel free to ask questions at any time by typing them in the IM window, and be aware that any questions you post will be publicly visible. However, if you prefer, you can post your questions anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. But I want to provide an additional mechanism to ensure any questions we miss get answered. If you'll visit us at aka.ms/ASCIoT community, you'll be able to ask questions to our Azure Security Center for IoT forum. If you're listening to this after the fact as a recording, that's also a great place to ask questions. We always love to hear your feedback on how we can improve these webinars. You can do so at aka.ms/security-webinar-feedback. Please note that this webinar is being recorded and it will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. While you are there, please join our community by visiting aa.ms/security-community. That's the best way to ensure that you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up at aka.ms/security private preview, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. Today, we'll be talking about Azure Security Center for Internet of Things, specifically about end-to-end security. Therefore, I'd like to introduce you to our presenter, Idan Perkal. Idan is a member of our Azure Security Center for IoT team who has a deep expertise in this topic. Without further ado, I'll turn it over to him. Idan, floor is yours.
Amazing. Thank you, Valon. So, hey, everyone. I'm very happy to be here with you today. My name is Idan, and I'm a PM at the team that develops Azure Security Center for IoT. Our session today will be focused on IoT security. We'll talk about the challenges in securing IoT devices, the anatomy of IoT-related cyber attacks. We will show you how ASC for IoT can help you protect your IoT solution, and even a very cool demo for IoT attack from both the attacker perspective and the defender perspective. But first, let's talk about the IoT big promise. So the digital transformation, which is enabled by the IoT adoption, allows you to evolve your operation, products, how you interact and engage with customers, empower employees, and even create whole new business models. It presents a new concept called the digital feedback loop that's composed of three parts: things, insights, and actions. And the flow is as follows. You start collecting data by connecting IoT devices to the field. You analyze the data you received, and then you act based on the analytics result. This is the holy grail of the digital transformation. And we already see a big adoption of those concepts across the board, with 24% of the companies expect to use IoT devices by 2021. The spend on IoT by manufacturers is predicted to increase to more than $200 billion. Add to that the data race. By 2025, there will be 80 billion connected things generating 180 zettabytes of data. And it's not science fiction anymore. Organizations which adopted IoT early are seeing the advantages. The most digital transformed companies are seeing a huge revenue increase as a result. But with this great promise comes a huge challenge. As the adoption curve of IoT devices becomes steeper, the attack surface to protect go correspondingly. Add to that the fact that there is a long tail of manufacturers that produce devices without any standardization and with so many types of different hardware and OS distributions. And we are seeing in a lot of production environments, legacy devices that can be 10, 20, and even 30 years old. Those devices have a huge known vulnerability list and are using unsecure configurations like open ports and naive default passwords. We will touch on it a bit later. All those inherent vulnerabilities from the defender perspective makes IoT devices an easy target for adversaries. And we are already seeing the number of IoT-related attacks is getting bigger and bigger. And actually, those trends are reflected in the numbers. According to a report by Kaspersky Labs from 2018, we can see the trend of attacks that infected IoT devices in honeypots they deployed, and is actually a great indicator of what's going on out in the wild. We can see a growth from 3,000 attacks in 2016 to more than 100K of attacks in 2018. It's a huge exponential growth, and the interesting part is that you can see those figures in every IoT security report. Surprisingly enough, 35% of the organization reported that IoT devices were the primary source of data breaches in their organization. We aim to reduce this number significantly. So let's talk about some famous IoT attacks. We will start with Mirai, which is maybe the most famous IoT attack. Mirai was or is a botnet attack that took place in 2016, in which roughly 100,000 IoT devices were compromised to run the DDoS, which is distributed denial of service attack, in East US on a famous DNS service provider. Those attacks resulted in accessibility to several high-profile websites that were down for around a day. And I want you to just think of the size of the economic damage to those companies. And I will give you a teaser. Our demo will run a Mirai attack, so stay tuned. The second one, and which is kind of famous, took place at the casino in Vegas, and it is publicly known as the fish tank attack. The casino fish tank was actually really cool and advanced, using a thermometer that connected to the internet in order to send updates about the water temperature. What was less cool is that they did a lot of wrong networking decisions. The thermometer was connected directly to the more sensitive CorpNet without any appropriate security measures. So an attacker was able to get the model of the thermometer and found a vulnerability in it. And then he started to literally move inside the corporate network. And in the end, he got to the casino crown jewel, the high roller database, and pulled all its data. So I think that by now I've convinced you that IoT security is a challenging problem. Those figures explains how heavily Microsoft is invested in order to solve it. The sole purpose of those investments is to bring the best security products to the market. And the way Microsoft builds security is based on three important vectors: secure foundations and intelligence, innovative technology, and continuous collaboration with our partners. The result is unmatched security solutions across your cloud and endpoint workloads. So I'm very excited to present to you Azure Security Center for IoT, which aims to address the IoT security challenges and to allow you to unblock IoT innovation while keeping your IoT assets safe. And our solution is built on top of four main foundations. The first one is that we are looking at the IoT solution as a whole, from leaf devices to edge devices and through Azure different services that are composing your IoT solution, like computing and storage resources. And we give you a single pane of glass to manage and monitor all the different building blocks composing your IoT solution. But it doesn't end here. Once all your IoT related resources are there, you can improve your security posture by using security recommendations that will help you increase your security hygiene and reduce the attack surface to the minimum. Third, we are leveraging millions of unique threat indicators that are generated every day by Microsoft and its partners to detect and alert you from new threats. And lastly, our product is built for the cloud. We are natively integrated to different Azure services like Microsoft's new SIEM service, Azure Sentinel. So when we build the product, we had you in our minds, and we try to make it as flexible as possible for your changing needs. We created two user interfaces. The first one is for the security operations team that can now use Azure Security Center to consume IoT related data. And the second user interface is for the OT and the IoT or IT operations team that can consume it directly from the IoT Hub. And we will explain a little further about IoT Hub later. Another thing we have done is creating several detection engines that will cover any scenario. So the first one is agent-based model, which is open sourced. Using it enable in-depth security visibility to your devices. The second one is agentless, which is based on IoT Hub, telemetry, and includes anomaly detection. And we also have a dedicated model specifically for IoT Edge in order to cover all the edge relevant scenarios. And lastly, we are using 3 levels of security. So we start with recommendations in order to improve the IoT infrastructure security hygiene and reduce the attack surface. The second level is alerts. Once your organization is infected, you want to know it as fast as possible. And so we provide you with alerts that cover IoT attack scenarios and based on threat intelligence that will be triggered once there is an indication for compromise in your deployment. Those alerts provide you aggregated and summarized information about the incident and allows you to drill down into the raw data to investigate even further. And lastly are the custom alerts. You have your specific IoT applications and you know how your IoT devices should behave. By using custom alerts, we allow you to create a baseline based on those behaviors. So as we saw in the start of the presentation, every IoT architecture is built on top of 3 main pillars. The first one is things, the IoT devices we are getting the data from. The second one is the insights, which are business knowledge we are generating based on the data we received from the devices, from the things. And the third one is actions, which are reactions based on the insights we generated. So let's see how this theoretical model looks like in a real deployment. So for things, there are 2 possible architectures. The first are devices that connected directly to IoT Hub with different OS types, from Windows Core to Ubuntu to Debian, and even RTOS, which is a MCU operating system, real-time operating system. The second possible architecture includes edge devices that will be used as an intermediate and aggregation layer and will communicate with the IoT hub on behalf of the devices. So a very important component that is responsible for the connection between the things in the field and the insights, or in our case, the backend resources, is called the IoT Hub, which is our Azure Cloud Gateway. And it is allowing a bi-directional communication between IoT devices and Azure services. And in order to generate insights, the hub is connected to storage and compute resources. You can use those insights to trigger actions in the devices in the field, leaf or edge devices, or to connect to other services like SIEM solutions. And we are aiming to give you an end-to-end security across all your stack. And the beauty is that once you onboard your IoT hub to ASC for IoT, we will provide security monitoring and integration for each component in this architecture. So with that, we will go to a product walkthrough. Great. So the first thing I want to show you is how easy it is to onboard to ASC for IoT. And right now I'm in the IoT Hub, which is the gateway to Azure and allows a bidirectional communication with the IoT devices. And what I need to do in order to onboard to ASE for IoT is go to one of the pages under the security plate. And when you will do it, you will find the onboarding page, which gives you general information about our solution, and you can get more knowledge and understanding about our solution. And the only thing you will need to do in order to onboard to our solution is to click on the Secure Your IoT solution. And what will happen is that in a one click of a button, the IoT hub and its related devices and all the hubs in the subscription group will be onboard automatically to ASE for IoT. And now we are actually onboarded to the service. So what I want to show you now, and it is through a pre-populated environment in order to give you more sense of the product, is a couple of important pillars in our solution. So this is the overview page where you can get a single pane of glass to all your IoT devices and related IoT application resources inside your organization. And what you can see here is device alerts and recommendations and the health monitoring of different resources in your IoT application. Down here, you can see resource and device security alerts by day, and they are splitted or divided into different severities. So you can get a sense of what are the security trends in your organization. The second thing I want to show you is the security alerts page. And the security alerts page allows you to investigate further alerts or suspicious activity in your organization. And those alerts are sorted by date and their severities. So you can get a sense, for example, let's go on this alert, and you can get a high-level overview about what is the alert, when it occurred, the severity, and the different devices that were affected from this alert. Let's go to the resources page. And here we can see all the linked Azure resources like computing and storage that you linked to your IoT application. And in a minute, we will show you how easy it is to do it. And you can get a sense of what are their security hygiene and what are the recommendations regarding to them. So for example, here we can see that 5 out of 13 recommendations are high severity. And by clicking on edit and choosing another resource groups, you can easily link new resources to your IoT application. And by that, ASE for IoT will start monitoring them and give you relevant security information like alerts and recommendations. The custom alerts page allows you to create different devices, security groups based on their behavior or operational role. And here, for example, let's create a new security group for the OT environment devices. And when entering into the security group, we can create custom alerts that can be specifically targeted to those devices. And for example, we can like list a execution of processes that is not allowed and give like a whitelist of allowed processes for this environment and these devices to run. And this is very important thing in IoT devices. IoT devices most of the time do one thing and one thing only. They run a specific processes, send a specific data format or data types in a specific time periods. And all this information you can create based on it. And each time a deviation from the baseline you defined occurring, and relevant alert will be triggered. And in IoT devices, when it happens, a lot of time it indicates about a suspicious activity in your environment, or it can be even operational things that it's very important for you as a IT operation or security operation to know about. The last thing I want to show you is how natively we are integrated into the security operation workflow. And once you onboard to ASC for IoT, a new tile will be added into the Security Center overview page, where you can now consume the health of IoT Hub and related resources, security hygiene. And the second thing is that after you onboard to ASC for IoT solution, you can even see the security score that reflected in your IoT Hub and environment, and can improve it by fixing the recommendations ASC provides you. So with that, let's talk about how IoT attacks behave and its main characteristics. So we can see here the top 10 attacks in 2018. And you can notice that it consists of a couple of malwares, but the most common one is definitely Mirai and variants of it. And I will try to explain the reason for this by reviewing the history of the attack. So the first publicly known Mirai attack took place in 2016. The target was a famous security blog called Curbs on Security. And in the end of the same month, Mirai source code was released publicly in GitHub. And a month later, the huge DDoS attack took place. You can see in the map the areas in the US that were hit. In those areas, people could not access a huge number of famous websites because of the fact that DNS there was responsible to redirect to those sites went down. And we actually look at Mirai as a template, since recent IoT attacks reused its framework and enhanced it. This is probably due to the fact that Mirai source code was published on GitHub by its author, which made it very easy task and caused it to be super popular and widely used by attacker communities. So in recent examples, like those we are showing in the bottom, we are seeing attackers using the same source code and adding to it new functionalities. A famous Golang Mirai variant, for example, collects SSH keys from all over the internet and try to use them to connect and infect devices. Satori and Reaper are using exploits in home routers and trying to activate them. Again, they take advantage of the fact that there are millions of connected devices out there in the wild. So even if their success rate is low and they are able to infect only a 1% of the devices, they are still able to infect a huge absolute amount of devices. So this is how a typical Mirai attacks looks like. And the first thing that happens is that scanners around the internet tries to see or check around the internet for IoT devices that have open ports that relevant for very common communication protocols like Telnet and SSH. Once they find devices with those characteristics, they're trying to connect to them using different list of known credentials. And once they are able to connect to one of the devices, they send its information like the device IP and credentials to a reporting server. What happens next is that a loader takes the device information in order to use a specific malwares that are targeted to those specific devices and take advantages of known vulnerabilities in them in order to infect them. And once the malware runs on the IoT device is now part of a bigger IoT botnet. And those devices are now communicating with command and control servers, which are giving them instructions to what to do in order to make different kind of malicious behavior, like DDoS attack, as we discussed in previous slides, or even things like crypto mining and earn the attacker money. So let's look at some interesting insights from Mirai source code. So here is a part of the credential dictionary Mirai is using. Those are default and very common credentials that devices are shipped with from the factory. And we will talk about it more deeply in the attack demo. Once able to infect the device, it will kill all external communication and make it much harder to remediate the device, because now it is unreachable, and the only way to access it is through physical login. When Mirai taking over IoT devices, it is searching for other malwares on the device and is killing them. And here you can see that in order to keep a low profile, it's actually decided not to mess with networks of some organizations. And in this example, it's the Department of Defense. So with that, we will go on over to the attack demo. So here we have an environment with devices in it. And what we will try to do, imagine that I'm now wearing my black hoodie and trying to hack to one of the devices. So the first thing that I will do is try to connect to the network where the IoT devices resides. So we will run an init script and give it as a parameter the SSID of the network, of the Wi-Fi network. Try again. Okay. So the next thing that I will do now is to scan the network that I'm in it in order to find if one of the devices have some interesting open ports. And we will specifically look into ports 22, which is an SSH port and used very commonly to communicate with IoT devices. So let's scan the network. Okay, so let's see the results. And what we can see here is that we have one device which runs Ubuntu and has a SSH open port. And this device is characteristic, reflects very well an IoT device. So I will bet that this device is an IoT device. And of course, that now we are seeing it has open ports. So we will try to target this one. And now let's move to the actual attack. And what I will do is to give the IP we found earlier in order to run the attack script and on the device. So the first thing we are trying to do, and it's very similar to what happened in Mirai attack, is that we are trying to do a brute force attack or a password dictionary attack, and actually use different combinations of usernames and password in order to access the device. And we are trying to use credentials that are very common to be a default credentials that manufacturers ship IoT devices with in order to limit the access to those devices where they are out in the market. And actually, Mirai used 60 combinations of usernames and passwords in order to penetrate to more than 100,000 of devices. And it's just an amazing fact. So now we were, once we were able to access the device, we ran a simple ls command and we can see the files inside the device. And what we will do now is first cover our traces. A lot of security solutions monitor the device once in a time interval. So if we covering and deleting log files that related to the connections we made earlier, it is very possible that some security solution wouldn't be able to to reflect that those logins occurred and give the relevant triggers. And the second thing we are doing, and this is very important step, is that because right now we can't run on the device code, we are asking the device to fetch from a remote website a script, and it downloads the script as a text file, give it the relevant permissions, and execute it as a script. And when it do it, the device is actually infected, and now we can do with it everything we want. So the next stage is to connect the device and make it more autonomous, and so we won't will be needed anymore to connect the device directly. And what we are doing here is asking the device to connect to a command and control server, and so now the device is like a slave, and the command and control server instruct the device what to do, and now we can disconnect the device, and the device will be still part of the botnet. And now from the CNC server, we are asking the device to do different things, like running for us a crypto miner and earn for me some dollars. So with that, I will put off my black hoodie and will show you how it looks like from the defender perspective. So let's go to the security alerts and see if we get any indication of the malicious activity that occurred in the device. So this is a live demo, so it could take a couple of seconds. Great. So we can see here now that in real time, the alerts were triggered, and let's talk about some of them. So we can see here the brute force attempt, which we discussed earlier, where the attacker tried to guess some password in order to connect to the device. And even more importantly, we can see here and get indication that after the password guessing attempts were made, he was able to connect the device. We can see here the reverse shell, which is indicates on a command and control like activities in the device, and even the fact that the device in the end ran crypto miner for the attacker. And the thing that I want to emphasize here is the suspicious IP address communication alert, which triggered by leveraging threat intelligence. And what happened here is that once the device communicating with outside resources, this IP gets sent and queried inside a threat intelligence list. And if we are finding that this IP is already triggered as a malicious, we are triggering the same relevant alert inside the customer environment, and so you can investigate and understand what happened in this specific scenario. We can see here different kind of alerts, like the user add command, which indicates that the attacker added a a new user in order to gain persistence in the device. And you actually from here can even drill down further and see details regarding to the relevant IPs and to the specific devices, and even connect this data into a SIEM system and investigate further. The thing that I want to emphasize here is the recommendation and the fact that if the customer was able to apply those recommendations inside his IoT network, the attack could have been prevented. We can see here the device has open ports, and we saw that we are leveraging the SSH port in order to start the attack. And if it is not possible to close this port because of business needs, we are asking for reducing the permissive firewall policy and harden it in order for outside IPs to not communicate with the device. And the third one is regarding the OS baseline, which means that the device is not patched. And if it were patched, it would make the attacker life much harder to penetrate the device and find relevant vulnerabilities in it. So just to emphasize the importance of hardening your environment, according to a report from 2018, the vast majority of IoT-related attacks are still caused by cracking protocols like Telnet and SSH. And you can even make it smarter, add to your baseline known geolocation that you should block in advance, and you will reduce the attack surface to the minimum. We are now working with the leading companies in the IoT landscape in order to secure their assets. We have launched a monthly call in order to keep our customer updated on all the new features and also new attacks and vulnerabilities. If you would like to participate, feel free to reach out. So we have GA 3 months ago, and while we are preparing new cool features to be announced in RSA, we want to give you a taste of those announcements and tell you that a new integration with Azure Sentinel is on the way with a number of investigation and very cool stories. And we are opening for private preview. So if you are interested, please feel free to reach out. I will finish by saying that you have seen how easy it is to onboard your IoT hubs to Azure Security Center for IoT. And if there is one takeaway I would like to give you from this session is to make sure you turn on security for your IoT assets. So with that, thank you so much.
Thank you, Idan. And some great questions came in along with some great answers, but would like to pick on one, especially from the anonymous. This is about the discovery process alone, which is a very significant challenge. And Lior, you provided a great answer, but if you can elaborate a little bit further. So the question goes as, how can we ever hope to have a single pane of glass for IoT management and security when there are literally hundreds, if not thousands, of different embedded operating systems of these devices?
All right, so this is indeed a great question, as ideally we'd like to have our AC for IoT agent installed on each one of the Leaf devices. However, this is not practical, as there will be various reasons, such as you're dealing with a legacy IoT device, or for some reason or some regulation, it's not permitted to install an agent on those devices, or specifically the IoT device is running on an OS which is not supported by ASC for IoT agent. In that case, you can still have a protection for those devices by the fact that those Leaf devices might be connected into an IoT edge device, which may run the ASC4 IoT agent. So it would not give you the same detection capabilities like if you were running on the IoT device itself, but it will still give you some very good coverage by inspecting all the traffic that goes from this IoT device via the IoT edge.
Thank you, Lior. One of the slides that Idan presented will show the security agents, and perhaps if either you or Idan can elaborate on the security agent options and the advice on choosing the right agent flavor for the clients for their solution.
Yeah, so we actually, as discussed, we have a couple of agent alternatives from agents that are relevant for Ubuntu and Debian devices through agents that are relevant to OS Windows Core. We are nowadays working on integration to RTOS kind of OSs, and we are supporting the edge models too. So you have like different flavors, and we are trying to even improve the coverage. But right now it's Ubuntu, Debian, Windows Core OS, and different edge devices.
Great, thank you. You mentioned earlier that from a UI perspective, people can view things both in Azure Security Center and Azure IoT. Can you explain a little bit of the difference of what you might view in those different interfaces?
Yeah, so in ASC, we are aiming for the security operations personas. We are giving you a health monitoring related information about the different IoT resources you deployed in your application, and we are giving you a relevant security score. While in the IoT hub flow, which is more of a DevOps or OT related perspective, we are letting you to deep dive into the alerts and recommendation in order to investigate and understand more deeply the security posture of your environment.
Fantastic. We had another question roll in here. How can someone respond automatically to an attack, taking an action based on an alert, for example?
So we are integrated natively to different Azure services because we are built for the cloud. So you can use different automation tools that you can find in the Azure ecosystem in order to make some automation related to it. You can connect the alerts and integrate them into SIEM system and then do relevant automations around the scenarios that specifically address your needs.
Thank you. So just a quick reminder, in case you have additional questions, you can visit us at aka.ms/ASC IoT community, where you'll be able to ask questions on our Azure Security Center for Internet of Things forum. I want to thank all of you, all those who helped answering questions. Lior, thank you for that. And thank you, Idan, for a fantastic presentation. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Thank you and goodbye.